Now, the other thing that we want to discuss here, we call it linear expansivity. From, we have said change in length is equal now to original length, linear expansivity, times the change in temperature. But linear expansivity is here. Now, let us make a subject of this linear expansivity. That is to say, now change in length is equal now to original length, linear expansivity, and change in temperature. Now we divide by change in temperature both sides, change in temperature both sides, and then we divide by original length. Mathematically, this and this cancel out, this and this cancel out. Are we together? Now, linear expansivity is equal now to change in temperature, change in length, times original length and times the change in temperature. And that is why this is the increase in length. Increase in length over the original length times the change in temperature. And that is why we say, now, whenever now we're talking about linear expansivity, is the increase in length over the original length and change in temperature. And that is why by definition we say is the increase in length per unit length of the substance when it is temperature rises by 1 degree Celsius or 1 Kelvin. 1 degree Celsius or 1 Kelvin. But this by definition, that is the mathematical definition data, it is the increase in length per unit length. The increase in length per unit length, that is according to the rise in temperature by 1 degree Celsius or 1 Kelvin. But the definition that you would have explained in terms of words, this is according to mathematical concept, but according to the definition that we may explain in words, we say is the ability of an object to increase in their volumes. Linear expansivity is the ability of an object to increase in their volume. That is the linear expansivity. Now, linear expansivity is the ability of the material to expand. Material that is solid to expand. So the ability of the material to expand, we call it linear expansivity. But mathematically can be explained as I said that linear expansivity is equal now to change in length over original length and change in temperature. But remember I've said change in length is equal to new length minus the original length. And the change in temperature is equal now to final minus the initial temperature. So this is very important for us to understand. So whenever somebody have told you to maybe to calculate the linear expansivity of the material, this is how we do it. So we have to calculate linear expansivity by using, but the formula that is very important, and the general formula I call it according to me, it is a change in length is equal now to original length, linear expansivity, and change in temperature. Due to the fact that this is very important whenever you're talking about thermal expansion in solids. So this is the change in length, this is the original length, and this is linear expansivity, and this is the change in temperature. So this is something very important for us to understand it. Are we together? So this is all about, you can define linear expansivity, that is the ability of an object to expand, we call it linear expansivity. Mathematically, how do we get it? We get it from this concept. It is where now we can obtain the linear expansivity on the material. Do you understand? So in case now you've been taught to define it, this is how we define. In case you've been taught how to calculate it, we use this formula or this one. But all in all, this is the formula that is definitely applied in finding the linear expansivity, finding the change in temperature, finding the original length, finding the change in length. Now, after we have seen, so now let us see some of the linear expansivity, because I've said this is constant, so the material may have linear expansivity. Example, now the SI unit the SI unit of linear expansivity. As we have said, change in length is equal to original length and linear expansivity change in this one. And we have said linear expansivity is equal to change in length over the original length and change in temperature. Now linear expansivity is equal to change in length over original length and change in temperature. Remember, this change in length is measured in terms of meter, and this over original length is meter, and this also is degree Celsius or Kelvin. You get my point? Now that is Kelvin or degree Celsius. Now mathematically this comes out. Then you remain 1 over K. Now the SI unit of linear expansivity is 1 over K. And that is why in short we write it is K negative 1. So this is per Kelvin. Now the SI unit of linear expansivity. SI unit of linear expansivity is per Kelvin or per degree Celsius. That is why in short mathematical we write per Kelvin. This is according to exponential forms that this is taken to the upper side, then becomes what? Negative. Now the SI unit of linear expansivity is per Kelvin. Now as I said, this is constant. It depends on the nature of the material. If now you're talking about plastic, we have plastic in the world wide, so it is something constant, and that is why we say some of the substance that may be explained. Aluminium is 25.5 times 10 power negative 6. That is per Kelvin. So this is for aluminium. It is constant, and it was determined experimentally. These things were determined experimentally. It is now where you can find linear expansivity. For the plus, we have it is 18.9 times 10 power negative 6 per Kelvin. Or copper, we have 16.7 times 10 power negative 6. That is per Kelvin. So linear expansivity is constant. So it is something that maybe you may be asked to determine, but all in all is something that exists and it is constant, and you have to know how to determine it mathematically, but it was determined experimentally for every material. If now you're talking about plastic, it have got it. If now you're talking about steel, that is 10.2 times 10 power negative 6. That is per Kelvin. That is steel. If now you're talking about let's say that is glass, the glass is 8.5 times 10 power negative 6 per Kelvin. Those are the what we call them linear expansivity of the sum of the substance. We have so many in the world. We have glass, Pyrex glass, we have invar, we have iron, we have steel, we have copper, we have so many things. They have got their own specific heat capacity. Sorry. They have got their own linear expansivity of the materials. Have I made myself clear? So this is all. Now let us see how we can solve some sort of the examples, study examples by using this concept.